we are talking about kinetic energy. Please write down the definition of the kinetic energy. Energy possessed by a body due to its motion. So here you can see that kinetic energy basically, I told you that kinetic energy is the energy possessed by a body due to its motion. देखो ये topic, it is very important topic because this topic we also have to cover in the case of energy, work energy and power. We will also discuss the same topic in the context of work energy and power, but here I am discussing this topic because it is also related to momentum of the body, because we have to solve some question related to momentum. In those questions of the momentum, we are going to apply the idea of the kinetic energy. That's why I am going to explain you that what is kinetic energy. Okay, so I told you that the kinetic energy is the energy possessed by a body due to its motion. It means if a body is moving, then it is possessing kinetic energy. Okay, for example, if the car is moving, it is possessing the kinetic energy. If you are moving, your body itself is having the kinetic energy. If you throw a ball, then the moving ball is possessing the kinetic energy. G. I'm telling you, just a minute. Now, first of all, how to calculate the kinetic energy of the body? As I told you that kinetic energy is depending upon the motion of the body. If the body is moving, then it is possessing the kinetic energy. Na? So, it means it is depending upon the velocity of the body. Okay? It is depending upon the velocity of the body. There is another thing over which it is depending. One more thing over which it is depending. Mass. Very good. So, the formula for kinetic energy, I am representing. Yes. To find out the kinetic energy, we can use this relation, that Ke. Here I am writing Ke. Ke stands for kinetic energy. Ke is equal to 1 by 2 m into v square. Here this square is only on v, not on m. Keep in your mind. Okay. 1 by 2 mv square. So we can see that kinetic energy is equal to half mv square. Okay. So for example, if we are going to take any example, like there is a body of mass, m stands for mass. Here I am taking the example of a body which is of mass 120 kg. Okay. Let's suppose that we have a body of mass 120 kg. It is moving with the velocity of 10 meter per second. Suppose this velocity of mass 120 kg is moving with the velocity of 10 meter per second. Yes. Now to find out the kinetic energy, what we are going to do? We are going to apply the values. Yes. Ke is equal to 1 over 2. The mass 120 into 10. Yes. How much you calculated? 6,000. Okay. After simplifying this, you got 6,000. What is the unit for energy? Joule. Keep in your mind that the unit for energy is joule. It is 6,000 joule. The unit for energy is joule. Whatever the type of the energy, keep in your mind that whatever the type of energy is, its unit is joule. And this is energy basically. Now, you must also keep in your mind that energy is a scalar quantity. It is not a vector quantity. Although we are applying the velocity here, but it is a scalar quantity. Energy is a, what type of energy? Whether it is kinetic energy, potential energy, chemical energy, elastic potential energy, whatever the type of the energy may be, it is a scalar quantity and its unit is joule. Now we are going to discuss a question. Yesterday we did it. We are just going to revise this question so that it must be clear to us. Now here in this question you can see that explain why the momentum is a vector quantity. Why the momentum is a vector quantity? Because motion has a direction and it whenever the body is moving, it always moves in a certain direction. And the yes, we had done it. Now next thing. Just a minute, bache. Now here you can see that I told you that in a laboratory test, a car of mass 1200 kg is driven into a concrete wall as shown in the figure. Now you can see that there is a concrete wall and the car is like this. A video recording of the test shows that the car is brought at rest in 0.36 second when it collides with the wall. The speed of the car before the collision is 7.5 meter per second. Now, we have to find out, calculate the change of momentum of the car. How to find out the change of momentum of the car? Well, so we have to find out the change in momentum. Change in momentum is also called impulse. So basically he is asking us to find out impulse, which is the final momentum. I am representing the final momentum with PF. PF stands for final momentum minus PI initial momentum. Okay, what is the initial momentum of the car? Yes, m1. What is the velocity? At what velocity the car is moving? 7.5 meter per second. The momentum before the collision, that is the mass of the car is 1200. I am finding out the final momentum. So finally, after colliding with the wall, the car comes to rest. So what will be the final momentum? 1200 multiplied by 0, because final velocity will become 0 minus the initial momentum. Initially the car was moving, before the collision the car was moving with 7.5 meter per second. So this same 1200 will be multiplied by 7.5. Okay, 9000. So here the negative signs comes. Basically it is showing that because this is the change in momentum and the final momentum is larger than the initial momentum, that's why this final negative sign is coming. So what is the unit for momentum? Kilogram? Kilogram meter per second. Or you can also apply the unit Newton second. These two units can be applied. देखो, momentum depends on velocity and velocity is a vector quantity, you know that. Okay. Now we calculated that final momentum mv minus mu or m delta v change in momentum, this or minus this minus 1200 and this. So this is basically our answer is correct. Okay. Now we are again coming to the question. Now here, next, the average force acting on the car. We have to find out the average force acting on the car. How we are going to calculate the average force on the car? Now here you can see that what is given. Here the time is also given. You can observe that time is given 0.36 second. We have to do something with this time, and we don't know that how much force is exerted. How to find out the force? Now here you can see that data that 0.36 second is the time, and we have also calculated the change in momentum. If you remember, I told you a formula that rate change of momentum delta P stands for change in momentum divided by time is equal to force. Acha, very good. Okay. Very good. So here you can see that we have already delta P is already calculated. You can see this minus 9000 is already calculated, which is the change in momentum. Okay, divided by 0.06. So here to find out the force is minus 9000 0.36. 25,000 minus 25,000. What should be the unit for force? Newton. Now, what this negative sign shows? Okay. Now here you can see that it is 25,000 Newton because it is the opposite force, stopping force. Because this is an stopping force. देखो ये force, this force which is applying on the car, the force which is going to be applied on the car is the force which is stopping the car. जी मैं खुद करता हूँ अल्हम्दुलिल्लाह. बिस्मिल्लाहिर्रहमानिर्रहीम. अच्छा जी, देखो जी, a different car. Now here he is saying that a different car has a mass of 1500 kg. It collides with the same wall, okay? And all the energy transferred during the collision is absorbed by the crumpled zone. You know that there is a crumpled zone in each car, like this. This zone is called the crumpled zone because this crumpled zone is for the safety of the passengers in the car, okay? This crumpled zone basically increases the time. Here, the energy absorbed by the crumpled zone is 4.3 into 10 to the 5 joule. Show that the speed of the car before the collision is 24 meter per second. Previously, the car which he showed, its velocity was 7.5 meter per second. But here in this case, he is showing the different car. Its mass is 1500 kg and the energy which is absorbed by the wall is this much, 4.3 10 to the power 5 joule. We have to find out what we have to find out? Show that the speed of the car before the collision is 24 meter per second. This we have to show. I have told you the formula to find out the kinetic energy. Here we are going to apply the formula for kinetic energy. What is the formula for kinetic energy? Very good. 1 by 2 mass into velocity square. Now here I am going to apply the values. Ke is already given. So I am writing here kinetic energy 4.3 10 raised to the power 5 is equal to 1 over 2, and the mass of the car, multiply the mass of the car 1500, and the velocity we have to prove. Okay, I have applied the formula. I have put the kinetic energy here on this side. Now you can solve this equation. You can make the V as a subject of the formula. 23.9 meter per second. This is the velocity. Here you can see that 23.9 is approximately equal to this. Okay? Okay, now the last part. Suggest what would happen to the car if it is traveling faster than 24 meter per second when it hits the wall. The other parts of the car will deform, bend, break, etc. or more damage. जाहिर बात है ज़्यादा तेजी से आ रही होगी, अगर वही कार ज़्यादा तेजी से आ रही होगी तो फिर ज़्यादा डैमेज हो जाएगा. Now here it is the question 104. State an expression for the kinetic energy of an object of the mass m that is moving with a velocity v. Now here I told you the formula. If you know the formula, what type of mistake you people commit? You write 1 over 2 mv square, that's it. This is wrong way of writing an equation or expression. Yes. Ke is equal to Ke. It is very important, right? Whether kinetic energy, complete word can be written, it is better, is equal to half mv square, because he is asking that expression of an object of mass m that is moving with speed v. So the mass for m and v for velocity. Next part. State and explain kinetic energy is a scalar quantity or a vector quantity. It is a scalar. I told you whatever the type of the energy is, that is a scalar quantity. Okay? It is a scalar quantity and direction does not matter. Okay? It is a scalar quantity and direction does not matter. The figure shows two fairground bumper cars. Stationary empty car 50 kg. This car is stationary and this car is moving with 2.5 meter per second. This is 50 kg. Here in this car, two passengers can be seen sitting here. Its mass is 200 kg because there are two. Please wear an. Okay. Acha ji. Now, the question is, the car with passengers of total mass 200 is moving in a straight line. It is traveling at 2.5 meter per second when it hit the stationary car of mass 50 kg. Now, after the collision, the empty car moves forward in the same direction at a speed of 4 meter per second. Please keep in your mind, concentrate to this part, that the empty car moves forward. This empty car moves forward with a speed of 4 meter per second. This is very important to concentrate on this sentence because the question will be related to this thing. Okay. For the car with passenger, he is mentioning that what you are going to do for the car with passenger. These are the important points which you must underline. While solving the question, it is better for you to underline the important points so that it help you out for finding out the correct formula to be applied. Okay, we have to find out its momentum when it is traveling at 2.5 meter per second. G, momentum when it is traveling at 2.5. How we can find out the momentum of the passenger car? This which is behind. Yes, what we are going to do? Momentum is equal to mass into velocity. Mass is 200. The mass of the car is 200 kg. 500. Very good. Okay, kg meter per second, or you can also write Newton second. Now, please bache, concentrate. Now next part. The speed and direction of its motion immediately after the collision. This is very important to understand. What we are going to find out about the passenger car. The car in which the passengers are sitting. We are talking about that car. We are not talking about the car which is without passenger. We are not talking about this car. Okay? Now, he is asking us that the speed and direction of its motion immediately after the collision. This part we are going to do. We have calculated this before the collision. And you know that the velocity, I underlined this. Its velocity, the velocity of the empty car becomes 4 meter per second. Okay? So, it means we have to subtract something. The momentum of the car with passenger minus the momentum of the car without passenger, because it is colliding with this car. So, देखो बच्चे, यार इसको दोबारा से चीज को समझो. Before the collision momentum दोनों गाड़ियों का क्या था? What was the momentum before the collision? 500 plus 0. And momentum after the collision? 200. The passenger car is having the mass 200. Its velocity is v, plus the empty car has the mass 50, and velocity of the empty car is 4. Okay? 200 v is equal to 500 minus 200. Now v is equal to 300 over 200 gives you 1.5 meter per second. Okay? And as for the direction is concerned, the same. Okay? Direction is the same.